No, I'd rather you watch it to
And you
watch
want to
it.
know what? I bet if you stopped doing it, like everyone would start looking at him and be like, "Mr. Hamrick,
That's probably
what the
right.
heck?"
Yeah. Okay, let's see. We got a rectangle and we have a couple diagonals in here. Yes. To the left, to the left.
You really just have to do that?
Sounds like a song.
Backwards for him, so I didn't
Sounds like a song.
Thank you.
Okay. Is that better? All right, here we go. Let's pay attention, please. Caleb.
I am silly.
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 Yeah.
You're acting silly.
You
'Cause I
you
am
talking to
paying
somebody else doesn't mean you're paying attention.
I take mental notes.
Silly.
Silly.
All right. We ready now? All right. This is 29 through 33. So it says, yeah. So it says F. Let's label it. Make it a little easier. That's E and F, G and H. It's a regular test, 100-point test.
I'm failing your class, Mr. Hamrick. What's up with that?
Start studying. Okay, watch. Angle FEG, FEG, this angle right here, they tell you that is 57 degrees. All right, and the first question says, what's angle GEH? GEH. Let's label it. See what I'm doing here? I'm marking these things because it makes it stand out a little bit more, doesn't it? All right, so that's, what did I say was? GEH, yep. GEH, that's this one right here. So look, they tell you this thing is a rectangle to begin with. It says quadrilateral EFGH is a rectangle. So if it's a rectangle, what's big angle E right here? It's 90 degrees. So look, these two angles, this 57 and this unknown angle that we're trying to find, they make up 90 degrees, right? So how did you do that, Kenny? How'd you get 33?
I just knew that 33 and 57 made 90.
Okay, or what's the math? Come on, give me some math to do.
90 minus 57 equals 30.
Right, 90 minus 57. That's the math, okay?
Shush!
Seriously. 90 minus 57, and that is 33. You do the math, and that angle right there is 33 degrees. That's it. Now look, I don't know if they ask you, I think they changed the numbers up and stuff like that, but let's just for fun, let's figure out some other angles in here. We've done this before, and we're doing it again, all right? So pay attention, because a lot of you guys, I think some of you guys said this was 57 degrees, like they were equal to each other. They're not equal to each other on a rectangle. When does the diagonal bisect the angle? On a rhombus. It's only when all four sides are equal. All four sides are not equal on this. It's a rectangle, so it's 90 degrees. You have to see the relationship. You can't just automatically make everything equal every single time. You have to look what's going on and see the relationship. Does that make sense? Okay, so it's 90 minus 57 is 33. If you add those up, you get 90 degrees. We good with that? Okay. So if this is 57 degrees, what do you think this angle right here where I'm pointing at? What do you think that? Why is that 57
Because
degrees?
they're alternate interior.
Very good. They're alternate interior angles. Remember, these two lines are parallel if it's a rectangle, right? Because it's a parallelogram. This is 57, this is 57 right here. Well, if this is 57, what's this angle right here? It's 33. You could find it two ways. Yeah, I said we've done this before. All right, but I'm doing it again just to refresh your memory. So look, if this is 57, you could find this by taking it away from 90 or looking up here, right, and saying they're alternate interior. It's the same deal. Agree? Okay. Now look, these are being, what's true about the diagonals of a rectangle? What's true about the lengths of the diagonals of a rectangle? They're equal to each other, and they also are bisected because it's a parallelogram. So what's true about EK, FK, GK, HK? They're all equal to each other, okay? What does that tell you? Look at this triangle right here, EHK, this triangle right here. What does these two sides equaling each other have anything to do with the angles in here? If these two sides are equal, what do you think?
It's isosceles.
It's isosceles, so that means the opposite angles are equal to each other. So if this is 33, what's this angle sitting right here? That's 33 as well, okay? So what does that make this angle? 57, you get it? So we come up here, and that's 57, because alternate interior. If that's 33, that's 33. You get it? So really, if we just find that one angle, we can find all these other things just by knowing one angle. Make sense? What about this one right here? We haven't talked about that one. 33 and 33, which is what? 66. And what do we do with that 66? From 180. Why 180? Where'd you get that from?
That's what triangles.
That's right. All the triangles, all the angles add up to 180. And so what is that? That's a 4 and that's a 1. 114? Is that right? Now, it may not be drawn to scale because that's an acute angle, isn't it? That doesn't look like 114 degrees, but that's okay. We're just going by the numbers, okay? Even though it doesn't look like it should be 114, it is 114, okay, according to the numbers that are worked out here. Does that make sense? Okay, so if this is 114, how do I find this angle right there? I'm not going to do all that. So it's 114, it's what? It's 100 and what? 80 minus 114. If you look here, we've kind of already done the math anyway, right? 180 minus 114 is going to give you what? 66. So that's going to be, oops, it's going to be 66. Another way, okay, let's go back in time a little bit. Can you with me? Another way we can look back. Look, this is this is an exterior angle to this triangle right here, isn't it? Took this, extended it out. All right, are you going back in time with me? Just, was it last chapter or chapter before? Something like that. Okay, this is an exterior angle. What's the exterior angle equal to? The sum of the remote interior angles. Right, remote interior angles. So I could have just done what? 33 plus 33 is what? 66. So I could have done it that way too. See how it all comes together? All right, that's kind of nice about this because it all fits, doesn't it? All the stuff we talked about before, it all comes into play here as well. All right, so now let's do this. If this is 66, what's this where the K is? Give me one reason. You could give me a couple reasons, but what's the easiest one? Vertical angles. If this is 114, what's this? This is 114 as well. Okay, so we got all those angles, and we're good to go. Make sense? Now look, I realize in that problem they didn't ask you all that stuff. I just showed it to you because you never know. For the fun of it. That's right. Wasn't that fun? It was a blast. Okay, let's do this. Let's redraw this. Cliff said he wants a purple triangle. That's kind of pinkish, isn't it? Let's go. What's this called? Amethyst. How's that? Is that better? Not atheist. Amethyst. Oh, we are? Yes, it is. We're allowed to talk about atheists. We're just, hopefully we're not atheists, but we can talk about it. There's nothing wrong with talking about it. Okay, let's do this. Here we go. We've got E. We'll do the regular problems now. I'll quit doing stuff for fun, okay? Even though this stuff is fun,
Why
isn't
does
it?
he call it fun?
Because it is. It is fun. All right, look. They did the angle thing already. We're not going to worry about that on 30. Let's do 31 with the sides. FK. FK is 32. Where's that? Right here. That right there is 32. So that length is 32. The question says, find EG. Find what this whole thing is from here to here. You say, well, wait a minute. What does that have anything to do with this? That's not even the same line. Well, we talked about this already. Remember, yeah, both diagonals are exactly the same, right? So if this is 32, that's 32. What is the whole FH right there? So what do you think the whole EG is going to be? The whole EG is going to be 64 as well. Make sense? Okay, but you got to know stuff, right? You got to know the diagonals are equal to each other. You have to know the diagonals bisect each other, so that's 32 and that's 32. All right? Got it?
Yep.
Okay. Says angle, we won't worry about that one. Let's do 33. EF. Let's do this in a different color. I won't erase all that stuff. We'll just, pink. Is that pink?
Yeah, that one.
Okay.
That looks kind of purple. Since
So,
you gave us homework on Mountain
EF.
Today.
Shh. Hush. Hush. Kaylee, please, enough. I can take it for a while, but not constantly. Okay. EF is 4x minus 6. Why is it yellow? Oh, it's yellow because I clicked on that other stuff. You want this pink, right? That's about the closest thing to pink as I have. Okay, it is magenta, but and then what does it say? HG, which is this bottom one, which is x plus 3. All right, this is easy. We did this yesterday, didn't we?
Yeah.
What's true about the lengths of those two opposite sides? They're equal to each other. So what do? Man, we've done this 100 times this year, haven't we? At least, at the very least 100 times. Watch, subtract an x from both sides, you get 3x. Add a 6 to both sides, you get 9. Divide by 3, you get 3. The question, though, says find what? EF. It says find EF. Do I circle x equals 3? No. Got to plug it back in. So make sure that you read the instructions carefully. Zara, you getting all this? Okay, it's a great way of paying attention. So it's 4 times 3 minus 6, right? I'm just plugging x back in for this. 12 minus 6 is 6. Okay, so EF equals 6. Okay, so if EF equals 6, what if they ask you HG? You could just plug this back into this, couldn't you? 3 plus 3, you still get 6, right? So this is 6, this is 6. Got it? Does that really help you find FG right here? You could find FG. How could you find it? They don't ask you to find it on these problems, but you could. Because look, you know, it doesn't matter which one you do, you know this whole thing right there is how much? 64. You know this is what?
6.
Now these are different problems, so you realize they're not even close to being drawn to scale. Okay, would you agree with that? Let's just make this, let's pretend it's a little more to scale. Let's say that's 4, and that's 4. What would this whole thing be? 8, and we got to find what this is, question mark. Okay, so what would you do? We've done this before. This is not new. We talked about this a bunch yesterday. You know this whole thing. You know it's a right triangle, don't you?
Yeah.
So look, you guys thinking at all, or are you just sitting there waiting? I have a feeling this is what you're doing. I have a feeling that you're just sitting there and just watching me and just letting me go to the next step. You know what you should be doing inside your head, inside your brain? What should you be doing when you try to figure out the next thing I'm talking about, okay? That's what you should be doing. I have a feeling some of you guys are just sitting there just watching me and seeing what the next thing I do is. That's not what you should be doing, okay? At least that's better than a few of you with your eyes closed, not paying attention at all. All right, at least you're paying attention, okay? But you got to make sure that you're thinking ahead. So look, we basically have a right triangle. Let's just redraw this on a smaller scale. What's this side right here, the hypotenuse to this right triangle? It's 8. Okay, I changed it. See? I did that a while back. I scribbled out the 32s. I made that 4 and 4. So the whole thing is 8. What's the bottom? That's 6. So I got to find this. Let's call it x. Okay? So let's find this thing right here. So what do we do? What's the...
8.
That's right. So which one's squared? Do I go 8 squared? No. This has to be where the c is. Remember this? I hope you're paying attention because a lot of you guys are not getting the gist of this. Pythagorean theorem means, and we are going to deal with Pythagorean theorem a lot more detail in another chapter. In fact, the honors class is in that chapter right now. But we'll get to it soon enough. But we still should know how to do Pythagorean theorem. So it's going to be x squared plus what? Give me a number. 6 squared equals what? 8 squared. The hypotenuse is always the one that's out here by itself. It's always the c. Okay? So let's see what we get. X squared plus what? 36 equals 64. Subtract 36 from both sides. This is something you should be able to do. So x squared is what? That's a 5, that's a 1, that's an 8, that's a 2. So square root of 28, right? Square root both sides. And you don't even need to put that into a decimal. So what is FG? It's the square root of 28. Okay? That's something that you should be able to do at this level. You should be able to do Pythagorean theorem and find this side right here. Now, they don't ask you that in the problems, do they? Okay, but if they did, you should be able to find it. So if you know the diagonal and you know one of the sides, you should be able to find the other side because it makes a right triangle, do Pythagorean theorem, and you're good to go. Make sense? Okay, enough of that. Recording again? All right, so we've got diagonals on this as well, don't we? So let's draw the diagonals. One here. One here. Now, are the diagonals equal to each other on a rhombus? No. What do the diagonals do on a rhombus, though? They form yeah, they bisect each other because it's a parallelogram, but the special thing that they do is that they are perpendicular, right? Now, they also do something to these angles, this angle up here, that they didn't do on a rectangle. What is that? Right, this angle and this angle equal each other, so the diagonal does what to the whole angle? It bisects the whole angle, okay? This is all review. I hope you're getting all this. Because I figure the more we say it, the more it's going to sink in. Don't you think? You ever hear the phrase repetition is the key to learning? Yeah. Now you heard it. Okay. It is a phrase that people use. Okay. So it's a rhombus. EB is 9. Where's that? EB. That's this part right here. Let's do that in a color. So that is 9. AB is 12. Angle ABD is 55. ABD, that's this angle right here. That's 55 degrees. Alright? It says find each measure that they ask for. So first of all, they ask for AE. Then they ask for angle BDA. I'll just list them all. They ask for CE, which is easy. And then ACB, angle ACB. So this is what they're asking for. So we don't have to go in order, but I don't know. Let's do it. Let's go in order. AE. That's probably the hardest one out of all of these to find is AE. Now look at it. AE, I don't know this, do I? If I knew what EC was, then I could say they're equal to each other. Now, are all four of these segments right here equal? No, that would only be equal on a what? Well, a rectangle. Rectangle, okay? All four of these would only equal each other on a rectangle, because remember, the diagonals are not equal to each other on a rhombus. Look, AC is a lot bigger than BD, isn't it? I mean, you can just kind of look. See, this is slanting more this way, so it's going to take a lot longer to get from C to A. All right, does that make sense? All right, so what do we have, though? Look at ABE, triangle ABE. You see it? Let me just darken it in a little bit. What should we darken it in with? Yellow. And let's even make it a little thicker. Watch. I'll even do a straight line, make it like nice. So look at this, and look at this. Right there. Okay? See that triangle? It's a right triangle. What do I know on this right triangle? I know two sides, don't I? I know this side and I know this side. So guess what we're going to use to find AE? We're going to use Pythagorean theorem again. And so how do we use it? So let's just call this little bit A. Is that all right? All right. So what do I got? A squared plus 9 squared. Remember, the 12 is the hypotenuse. The 12 has to be by itself. So it's plus 9 squared equals 12 squared. Say, let's do the math. So that's A squared plus 81 equals 144. Do the math. Whoops, sorry. A squared equals, what's 144 minus 81? That should be 63. 63, right? So 63. What do I do with the squared thing? Take the square root of both sides. So A is the square root of 63. Do they write it as a decimal? Yes, they do. Somebody do that for me. 7.9? Okay, so A is approximately 7.9. Alright, so there you go. That's your answer, 7.9. And that's what this is, 7.9. That doesn't look very good. And watch. Look, if AE is 7.9, that's ugly right there, but you get it. 7.9. If AE is 7.9, look at CE. What do we know about CE? That's going to be 7.9 as well, because what's true about the diagonal? What's happening to it? It's being what? It's being bisected, so that's 7.9 as well. So without doing any extra math, I can figure out what that is. That was the hardest thing to do out of the whole problem right there, was that. Joel?
No.
Okay. All right, makes sense? You see the right, everybody sees the right triangle, don't you?
Yeah.
So nice and bright now in yellow. Okay. Let's look at angle BDA. Let's do this in a different color. Let's go light green. Okay. BDA, we'll find it. BDA, it's this one right here. Well, again, what do we know about the angles that are made by that diagonal? No. This angle and this angle right here. They're equal to each other, aren't they? Because they're being bisected. On a rhombus, the diagonals bisect each other. So that's 55. Now look, what's true about the opposite angles? The opposite angles are equal. So guess what this angle is right here? Right. This is 55 as well. So this angle is 55, and so is that angle right there. You see why I'm showing all of these? Because they could have asked you this one, they could have asked you this, couldn't they? All right, and it's just 55. No math involved at all. But you got to know stuff, though, don't you? You got to know that the diagonals bisect the angles. You have to know it. All right, if you don't know it, then you don't know what to do. You might just guess and get it right, but some people might say, oh, take it away from 90. But would you even take it away from 90? No, because on a rhombus, these angles right here are not right angles, are they? Unless it was a square, and they didn't tell us it was a square. Okay, so that's 55 and that's 55. Makes sense? ACB, let's find ACB. ACB, that's this one. Let's go different color again. Let's go blue. This one right here, this blue angle, we'll call it. we got to find out what this angle is equal to. They're not all 55 though, are they? Because this angle is different from this whole big angle right here. But what's true, let me ask you this. What's that whole big angle D equal to? 55 plus 55, which is 110. Right. So, what's that? You could have done that. You could have done that too, yeah. There's a couple ways you could have looked at it. That's 90 degrees, isn't it? That's 55. There's probably a better way to do it, tell you the truth. But I'll show you this way too, just to show you that it works as well. So you're right, Christian. This is a better way to do it. So if this is 55, that's a right angle. So you have a right triangle right here? Okay, so what do I do to find this missing angle? Yeah, add them up, take them away from 180. But let me show you a little trick. On a right triangle, you're always going to have a what? A 90-degree angle. So you're always going to go 180 minus 90, right? Which is 90. So these two will always add up to 90 degrees. So instead of going through the whole thing and saying 180, add them up, take them away from 180, you could just do what? 90 minus 55. That's a lot quicker and easier, isn't it? So when you have a right triangle, if you have one of the angles that you know, you can just find the other one by going 90 minus 55, which is what? 35, and that's that angle right there, 35 degrees. Does that help a little bit? Okay, so there you go. What about the kite? We haven't done kites yet. Might as well hit them all, right, while we're reviewing. So let's do a couple of problems where it has to deal with a kite. Actually, let me go, I'll pause this. All right, here's some information. In the book, they tell you that this right here is 12. They don't even give you a letter for that. That's fine. You don't need it. They tell you this is 12 and this is 15, and they ask you to solve for GH. GH is equal to what? All right, let's get red. So look what we have. On a kite, how do the diagonals intersect each other on a kite? Remember? At 90 degrees. Exactly right. Okay, on a kite, they intersect each other at a 90-degree angle. They're perpendicular to each other, those diagonals. You with me so far? It's really all you had to know about the kite. That's it. Now, in order to find GH, look what we have. Let's do this again. I think it makes it stand out a little bit. Actually, I should have made this a little thicker. Let's make it a little thicker so it stands out. It's supposed to be red.
It's like blood red.
Blood red? Sounds scary. We are, yes. Alright, there's my triangle. It's nice and highlighted right now. Look what we have. We have this length is 12, this is 15. We're trying to find GH. So as far as our A, B, and C with Pythagorean theorem, what would I call GH? Let's call it C, all right? Because the hypotenuse is always the C. The two legs are your A and B, okay? So now this is a little different. This is actually a little easier than what we did before. So it's what? 12 squared plus 15 squared equals C squared. So now that's 144, calculator. What's that, 120 or 225, is that right? 225 equals C squared. What is this? 369. Okay, equals C squared. Take the square root of both sides. What do you get as a 19.2? All right, and that's the answer, isn't it? That's the answer that they ask for right there, 19.2. Pretty easy, isn't it? Right? Got a calculator. You can plug that stuff into a calculator. But you got to know it's a right triangle. This is what you had to know. You had to know that these diagonals of a kite intersect each other at a right angle. If you know that, then you can do Pythagorean theorem and find the other missing side. Are we getting good at Pythagorean theorem now? We should, right? We should. Now you learned this in Algebra 1 though, didn't you? Pythagorean theorem? Probably. Yep. 8th grade you learned it? Okay. Good. So we're going to use it a lot more in another chapter. Remember I have a whole chapter on right triangles. We're going to use a bunch of it then. Okay. There's one more trapezoid problem. Might as well do that. We got a couple minutes here. Okay, so let's do this. What haven't we used yet? What's a good one?
What if there's 6 colors at the bottom?
Let's use it. I don't know what the difference. They call them global. I'm not really sure what the deal is, but they're all the same. It looks just like that. Yeah. Okay, here we go. You ready? Okay, we're not done yet. So that looks like that. That looks like that. Comes down like that, like this. Okay. So what does this look like?
Trapezoid.
Looks like a trapezoid, but we don't know until I do that. Now you can tell me it's a what? Now you can tell me it's a trapezoid. Look. Look, that's 112 degrees. That side is 23, and this side, I didn't really draw it like that, but we'll say it is. We'll say that's 23. And it says, find this angle up here. No, we don't even have to do that on this. Okay, let's take a look. This is not just any old trapezoid. This is 23 and this is 23, so tell me something about it.
It's a quadrilateral.
Well, it's a quadrilateral, but it's... Come on. Two sides equal
They're
to each other.
congruent.
Two sides equal to each other. Isosceles, right. It's an isosceles trapezoid. I didn't really draw it as such. I'll tell you, it kind of bugs me a little bit. Probably more like that. What's it look like? It's flat?
I think the upper one is down.
Well, it's because I didn't draw it real perfect. Anyway, it's fine. It's fine. It's fine. It's fine. Here we go. Watch. This is if this angle. Look, this is the angle we're trying to find. Correct? If it's an isosceles trapezoid, this angle is equal to what? This angle right here. Not that we're going to use that. I'm just showing that just so that you remember. Just for the fun of it, right? Excuse me. So, if I want to find this angle right here, what do you think is true about this 112 and this unknown angle? Look, parallel lines, cut by transversal. Are they equal to each other? What are they? They're supplementary. Okay, exactly right. They're supplementary, which means they equal 180. So what's the math involved, though? 180 what? Minus 112. And so what's that? 68? Okay. So that right there is 68 degrees. Now, again, for the fun of it, what would this be right here? 68. And if this is an isosceles trapezoid, what's this one? This would be 112. Okay? That's all they ask you on that particular problem right there. Pretty easy stuff, isn't it? All right, look, we hit pretty much all the highlights of this chapter just in that little section right there. We hit a few yesterday, but those were the big things. I recorded it. You don't have to watch every second of it, but skim through, you know, to the parts where you're not really sure about. If you're not sure about the kite, if you're not sure about a rhombus, if you're not sure about a rectangle, and the differences between all those, you know, go through it, watch that little bit, and there you go. All right. So, yeah. Okay. There's a practice test I want you to do on page 449. So this is from the book. Okay. This is from the book. It's page 449. What I'm going to do is I'm going to collect all these review things the day of the test so you can hang on to them and use them to review. Okay? So this is called practice test. This is homework. Okay? So this is practice test, page 449, and you're basically going to do all of them. So it's 1 through 25. And that's good practice because how many questions are on a test?
20.
20 of them. So let's see if there's anything we can skip in here. I'll tell you what. Let's omit a few of these.
Okay.
Let's start from the beginning. Actually, we're pretty much doing all of these. Yeah, do them all.
Do you
Sorry.
have Kenny?
Yes, I do.
Can I see him for a minute, please?
Okay. All right, so do them all. 1 to 25. 1 to 25. That's your homework. Enjoy it.
Hammer.